Alright folks, it's Bass Action back in action here. In this video we are going to look at how to graph cosecant and secant functions. What we're going to do is we're going to look at those in terms of sine and cosine, since our cosecant and our secant are simply the reciprocals of the sine and the cosine graphs. So what you can see here is that I've started off with a sine graph and I've got a cosine graph. And what we want to remember is that since they're reciprocals, what's going to happen is that anywhere our sine graph crosses the x-axis and thus equals 0, the cosecant graph will then create an asymptote. So you can see I've got a little bit of a reminder here that the cosecant of 0 is undefined and the cosecant of pi is undefined. You know, of course, this is where cosecant is undefined, but I've just listed two of them here. Graphically, when we look at this, we're going to find all of the places where the sine graph crosses 0, and that's going to create asymptotes. Okay, asymptotes are vertical asymptotes are anywhere a function is undefined. And then once we create those asymptotes, we take the actual portions of the sine curve that's between those, and we're going to sketch the reciprocals. So the point where it equals the -1 will just still stay that point, and then these will become, they almost look like little parabolas, but they're not parabolas because they're going to approach an asymptote. But that's kind of a feel that you can think of, is that they're going to approach these asymptotes and we're going to approach the asymptotes. So really we're not going to graph a cosecant graph, we're going to graph a sine and then do its reciprocal. We can do the same thing over here with our cosine graph. A little reminder that the secant of pi over 2 is undefined and the secant of 3 pi over 2 is undefined. And again, there are an infinite number of places where it's going to be undefined. It's going to happen anytime the cosine graph crosses 0 or crosses the x-axis, which means it equals 0. So anywhere we've got it crossing, we're going to create a nice vertical asymptote. Then between those vertical asymptotes, we are going to sketch in these reciprocals. So just like I was saying on the cosecant graph, we're not going to actually graph a secant graph. We're going to graph the sine or the cosine graph, and then we're going to do its reciprocal. So this video pretty much serves as a review of how to graph a sine or cosine graph. We're just going to layer in the cosecant feature. So as a reminder, when we look at this equation, what we're going to do is we're going to say, hey, we want to graph cosecant, but we're going to think in our mind as we're doing our initial graph, we're going to think, hey, cosecant is the reciprocal of sine. So we're going to graph a sine graph and then we'll flip the whole thing. As we look at this, we can see that there's a vertical translation. We're going to grab that here from the 3. So we're going to shift our graph up 3. So one of the things that we could do right away, depending the order you like to do it, is we could come down here to our grid and count up 3, 1, 2, 3, assuming we're wanting to make each little check mark equal to 1. And I like to draw in this little center line. Now, it's not physically part of my graph, but it just serves as a nice visual of where I'm supposed to be doing my graph and I'm going to be counting from. My amplitude, remember that's going to be an absolute value of that coefficient in front of the cosecant, or in our mental state right now, we're thinking sine. So the absolute value of that A value is going to be 5. So that means that from our center line, we're going to go as high 5 and as low, and we're going to go down to a -2. And we could even mark that on our graph if we wanted. 1, 2, 3, 4, 5, and we could mark that on there. I'm going to mark this up here as an 8, and then I'm going to go down to a -2 just to have that on my graph and give myself that key spot already. Is there a reflection on this graph? Yes, we are going to have a reflection on this graph. And when we look at this reflection, remember we're looking at that sine in front of that cosecant graph. Our period, what we want to call our attention to is that there is both a phase shift and a period change on this. So we're going to need to do a little bit of work. Now the period part's going to be pretty easy. We can do that part right away if we wanted. Remember the period is going to be 2 pi divided by this coefficient, so 2 pi over 2. So our period of this graph is going to be pi. And then I like to find my first starting point. So when I do my starting point, I like to grab this entire expression. So 2x minus pi, I set it equal to 0.
So 2x equals pi, so x equals pi over 2. So my first key value is going to be at pi over 2. Now, when I space out those key values, I'm going to take my period and I'm going to divide it into 4 pieces. So my period I already decided was pi. I already calculated that. I'm going to divide that into 4 pieces. So I'm going to space my pieces out, each key point, pi over 4 units apart. Now, when I go to calculate those, I'm going to take the starting point of the pi over 2 right here, and I'm going to add to that a pi over 4. Now, what's important to remember is that, especially when you're trying to do one on a scaled grid, if your teacher wants you to do these on a scaled grid, you might need to remember that that pi over 4 could be a plus or minus. We can go in either direction from our key value, and whichever way is going to fit our graph the best. We also are going to need to decide how much we want each of these vertical lines to represent, okay? So what I like to do is I like to find that common denominator, and since my smallest value here is denominators going to create pieces of pi over 4, I'm going to multiply my pi over 2 by 2 over 2. So I'm going to make each tick mark value worth pi over 4. So I've starting at this 2 pi over 4, which is pi over 2. So 2 pi over 4, and I'm going to add the 1 pi over 4. And when I do that, I'm going to get a 3 pi over 4, a 4 pi over 4, a 5 pi over 4. Remember, we'll reduce these when we get to the graph, and a 6 pi over 4. So when I go to start marking this, my first value is going to be at 2 pi over 2. I've already decided that each tick mark is going to be worth a pi over 4, so I'm going to count 2 over, so 1, 2, and I like to make my marks on my little center line to remind me where I'm counting from. And then from there, I'm going to start counting 1 pi over 4. Now, I'm going to graph a sine graph with a reflection starting right here. So sine's going to, my first point's going to be here. Sine is going to go down first because this has a reflection. So my next point is going to be down here. I'm going to graph the whole sine graph. Then I'm going to come back up. Then I'm going to come up to the 8. Then I'm going to come back down. And that's going to get me a whole period of sine. So let's go ahead and mark this graph. And again, you can kind of choose the order you like to do this. This is my pi over 2. Then my next value is going to be at a 3 pi over 4. Sometimes these get kind of crazy to graph. Then my next one's going to be at a pi. Then I'm going to have my 5 pi over 4 and my 3 pi over 2 because I'm going to reduce that. Now, when I sketch in this sine graph, that's going to give me a graph that looks like this. Now, since I'm going to need to turn this into a cosecant graph, I'm going to add a little bit more. I am going to go ahead and I'm going to come back here, and I can even come back around more. And notice that now I actually could create a sine graph that doesn't even have a phase shift, and that's okay. The key thing that I want to be able to do is I want to be able to now draw in the vertical asymptotes anywhere the sine graph crossed this center line. That's another benefit of drawing in that center line, is that helps create that visual. So as I'm going to reflect this, I'm going to draw in these vertical asymptotes anywhere my little sine graph is crossing my shifted center line. And I like to be able to draw full little curves between those asymptotes. So when I sketch this graph in, I'm going to actually sketch it here in black. My cosecant graph is going to take each of these little pieces and it's going to flip these. And it looks pretty skinny. You could have chosen to space these out more if you wanted. Now, the domain of this cosecant graph, remember that's going to be an x such that x is not equal to, and what we want to do is we want to grab an asymptote. We can see we have an asymptote here at 0. We could grab this pi over 2 if we wanted. I'm going to choose to grab the 0. So this is going to be any asymptote. Always try to pick one close to 0 if you can. Plus, then we want to figure out how far apart our asymptotes are, and that's actually just going to be half of the period. So we can write that as a little reminder. In this case, it's pi over 2. You can write your reminder, 1/2 the period. and then we're going to put a k because that's going to allow us to put in whole numbers for k and generate any future asymptote that we would want to do. Our range is going to go from negative infinity up to this low point here of the original sine graph. So it's going to go up to a -2. It's going to be inclusive and not inclusive on the infinity. Then we're going to restart at the 8, and we're going to go to positive infinity. Okay, so the key thing is being really comfortable with your sine and cosine, then being able to draw in those asymptotes and flip it.